Good evening to everyone.
Good evening, sir.
Okay, so we will see today the magnetic compass, the remaining bridge equipment. Then we'll start today with the GMDSS also. So let's see. First, I will start with the Solar's regulation for the magnetic compass. So it is given again the carriage requirement in the chapter 5, safety of navigation, regulation 19. And the para is 2.1 and 2.2. Okay, so this is the regulation. Now this says that all ships irrespective of size shall have a properly adjusted magnetic compass or other means independent of any power supply to determine the ship's heading and display the reading is the main steering position. So this regulation is for all the ships. So all the ships supposed to have this one, and independent of any power supply. This is the important. Just see here, there is something is written independent of any power supply. Means this magnetic compass basically it is not required any power supply. Okay, it is not going to have any power supply, and it should determine the heading and display the reading at the main steering position, that is near the autopilot or wheelhouse. That is what it is there, wheelhouse in bridge. Okay. Wheelhouse where the autopilot is located. So generally you will find this heading indicator or bearing, that is we say bearing indicator, that is there. This is selectable. We can select to the magnetic compass, gyro compass, and GPS. So all the three are selectable. So we can select this one. So it is going to indicate the magnetic compass. So this is the meaning, and this is the Solar's requirement. Okay. Now next what it is saying is a sphere magnetic compass interchangeable with a magnetic compass interchangeable with the magnetic compass as referred above. The meaning is here that is the fitted one, that what the magnetic compass is there. One spare also supposed to be there. It is kept. One spare supposed to be kept. Magnetic compass. Or there is a option here, or other means to perform the function referred above by means of replacement or duplicate equipment. So it is interchangeable with the magnetic compass. So a spare magnetic compass can be fitted, okay, or it can be interchanged with the above magnetic compass, or the spare magnetic compass is there, so we can replace also this. Okay, we can replace with that. So this is about the spare magnetic compass. Generally, the spares are kept on board ship. So this is the two regulation is there regarding this one, magnetic compass. Now, when we are going to study about the magnetic compass, that we should know that there is a rotating, okay, there is a pole. So there are the, suppose this is a earth or globe, and it is going to have a rotating axis, its own rotating, or this is the spinning axis. This is the spinning axis, and there is a Earth is going to have its own magnetic pole. So one is the spinning axis, and other is a magnetic pole. So this magnetic pole, or this is this one is known as a meridian. Okay, this is a meridian, and this meridian is known as a magnetic meridian, whereas this meridian, sorry, this meridian is known as a geographical meridian. The spinning axis and this line which is passing, okay, that is known as a geographical meridian. Whereas where the magnetic pole, we are going to have two poles, magnetic poles, and these poles are where this line is passing through that is known as a magnetic meridian. What I want to tell you is, this is what the pole, this pole is known as a magnetic north pole. It is a magnetic north pole. Okay, and similarly, this is also known as a magnetic south pole. Like the magnet, in the magnet, we know it, there is a north pole and there is a south pole. Similar to that, the earth is also going to have a magnetic north pole and magnetic south pole. Okay. But what about this pole? Here it is making a pole and this is known as a true north, true north. Or in other terms, it is also known as a geographical north pole. But very simple to remember, that is true north. So try to remember true north, that is the more easy to remember. And here it is making, that is known as a true south. So true north and true south. Now, if we are going to hang a magnet, if we are going to hang a magnet, okay, so it is going to align with the magnetic line of the earth. So it is going to align with that one and it is going to give, thus it is going to give the direction. So where it is going to align, always it is going to align north and south pole of the earth. Okay, it will be aligning. So it can use for the direction finding. Okay, it can be used for the direction finding. And this is how, this is the working principle of the magnetic compass. So we can say magnetic compass is a navigational device which provides direction of ships heading by settling to the magnetic north. Then this is the one. Second is the working principle. Working principle of a magnetic compass is when a small, a very small magnet bar is freely suspended. Freely suspended means it is hanged basically, or freely suspended. Freely suspended, then it always aligns parallel to the lines of force of magnetic field of Earth. And thus establish a direction. Okay, so this is a working principle as I have told you. Uh, so it is going to now how to make it means how the magnetic compass is made so it is freely suspended because it has to suspend freely. So we are going to make it in that way. So what we are going to do is we are going to take a housing that is known as a bowl. Okay. And in that we are going to fill a liquid so that it is going to it is going to become a frictionless. Okay, it is going to become a frictionless. So it is not going to move with the ship's movement. If the ship's direction is changed, it always supposed to point to the magnetic north. Okay. So structure. Okay, I am making a structure. What it is there. Then in the structure we can write it consists of a card. Card means where we have the 360 marking. Okay, this is a card. This is known as a card where we have the marking 00. Here is the 0 marking. Here it is going to be 90, 180, 270. This is known as a card. Okay, this is known as a card. So just I am putting in the bracket. Okay, this card with cardinal graduations. Now this cardinal graduation, this marking are there 10 degree, 20 degree, 30 degree, 90. This is known as a graduation, cardinal graduation. So this marking will be there in this. Suspended inside a bowl. This bowl is filled with liquid and card is immersed in it. Now this liquid is known as supporting liquid with supporting liquid. Supporting. Now what this supporting liquid is? Supporting liquid is supporting liquid is distilled water plus glycerin plus alcohol. Okay, so this supporting liquid is distilled water, glycerin and alcohol. Distilled water and glycerin, this is going to give a required density. Required density. So this required density, what will happen? This card will float basically. This card will float. Otherwise, uh, it is going to basically sink. So it should not sink, it's supposed to float. And that's why a required density is required. So there is a percentage that will be given in the manual. How much the distilled water or glycerin, or they generally say to take the supporting liquid from the maker itself. So they supply that one, and we generally keep as a spare the supporting liquid. Alcohol is basically anti-freezing element. So in the cold area also, it is not going to freeze, and that's why this alcohol is being mixed in it. Okay, due to the antifreeze. Now this card which is there, this card, beneath the card, okay, there is a needle that is attached to this card. Okay. So I will just write that one also. A needle magnet, a needle magnet is attached to the card. Okay. So let's see how it looks like. So at least you will understand a little bit about this one. So this is a side view. Okay, this is a side view again, and this is a side view. This is a float. You can see this one is a float, and here at the bottom of this one there is a magnet. This is the needle system, means needle magnet. This is the magnet. This is a pivoting. Pivoting means it is just fixed here like this. Means these full parts are just fixed here. Okay. So basically it is not going to strike anywhere. That is the reason. Otherwise it is going to float only in the liquid. So we are going to have a filled with the liquid in this one. This is the top liquids are there in this. So this is fully, it is going to be immersed in the liquid. Now this is a compass card. So this is a 360 degree. It is not shown because it is a side view. So it will look like this. Okay, so it is just shown half, but basically it is a circle like this. Okay, it is going to be a circle like this. So this is a card. So this is a card. It is just mounted on these hollow parts. These hollow parts or this float of the copper is generally blackened. If you see from the top, just I show you one, so you will also come to know. So that is a part that is going to be hollow like this. Okay. I will just keep it side by side here. It is very big. If you see this blackened parts, what you see here, sometimes it is transparent also. So you see this part actually. This is the part you see. This one is the part. Sometimes it is transparent also. And here, this white color around this one, this is a card. So only this is a card basically. Okay. Now there is a looper line. So here you are going to have a marking here like this. There is a marking here, and this is known as a looper line. That is going to give you the direction basically. So whatever the ships is going to rotate, so how much it has steered, direction it has changed, we can find out by this blue bar line where it is matching with the card readings. Okay, so that it is going to be. Here we are going to have this is the magnet that is being attached with this one. Here it is already written liquid, water and alcohol. And here it is given the gimbal socket. So you can see there is a gimbal here. This black ring, what you see, this is known as a gimbal. Now, what is this gimbal is basically? This gimbal is going to neutralize the effect of roll and pitch. It is going to neutralize the effect of roll and pitch. So the bowl is fixed in gimbals. Now, if there are one gimbal, so 1 degree of freedom. If it is 2 gimbals, 2 degree of freedom. If 3 gimbals, 3 degree of freedom. So likewise, how many gimbals are there? That many degree of freedom will be there. So eliminates the effect of roll and pitch. Movement of shape. So this card is going to be steady always. Okay, it is going to be steady. Because if the ship is going to roll and pitch, this gimbal is going to stabilize this one. Okay, so this is not going to have any effect of the roll and pitch. So this card looks like this. Okay. Now, question is, there are the certain questions are there in this one. Let's see about that. Question is why it is fitted. A magnetic compass, a mag compass is usually fitted on the upper bridge. Upper bridge means upper deck of bridge. Okay, that is also known as a monkey island. Yes. We should mention upper deck of bridge. The bridge deck on top of that upper deck of bridge. Okay. Now, why it is fitted on the monkey island? That is the question. Anyone? Anyone? Okay, there are the two reasons why it is fitted here. Okay, one reason is the answer for this. It does not have any effect of current carrying cables. Current carrying cables. Now we know that if we are
Sir, it does not have or does have?
no, oh, it does not have, sorry, does not have any effect of current carrying cable. Now we know that if current is going to flow in a cable, okay, it is going to have the magnetic field. Okay, it is going to have its own magnetic field. This magnetic field, it is going to affect this. Okay, and that's the reason why generally it is put in the monkey island, and generally this cable are not going to pass around this one. This is the one. Second is that if nearby there is a iron structure. Iron means ferrous materials. Ferrous materials are nearby, which can magnetized by magnetic lines of force of Earth. Now, if it is magnetizing, what will happen? This is going to again, it is going to have the impact. It impacts the magnet or magnetic compass, mag compass readings. And that's the reason you will find where the magnetic compass is there, nearby, there is no structure. Okay, no structures are there due to this reason. This any ferrous material which is going to magnetize, like our ship's hull, ship's body, and all, even the uh, all the structure is still, because the steel is also made of the iron only, and they are going to get bulkhead and all, they are going to get magnetized. And if it is getting magnetized, this is known as a gouging effect. Okay, gouging effect. And due to this gouging, you might have seen sometimes on board ships, if you have a laptop or you have a TV screen, color TV especially, the color changes when the ship is moving continuously in one direction. Continuously, if it is going in one direction, okay, the color at the corner or somewhere, the color, it is basically the color, different colors is coming. Okay, that is due to the magnetizing, because it gets, TV gets magnetized and it is changing the color. Okay, that is the effect, that is the gouging effect. And due to that, this also can impact or affect the magnetic compass reading. And that's why this is generally fitted in the upper deck of bridge, Monkey Island, that is known as a Monkey Island. So the current carrying cables are not there near to that. And second, there is no structural. Structural means bulkhead or any body, six structures is not made. So which can get magnetized and which can impact the magnetic compass. Okay. Then why these magnetic compass are still in use? So that is the one question. Okay, why magnetic compass is still it is in use? As I have told you, starting of this lecture, it is still in use by Solar's regulation. By Solar's regulation, because it does not require any power supply. Does not require any power supply And in case of power failure, it it will work. Okay, it will work. So what is the advantage we have? If we do not have the power, then what we are going to do? Yes, we can do little bit. Little bit means if 6 is in a momentum, so at least we can maneuver the ship to the safe area where ship cannot ground or collide with. So it can go to the safe area and put the anchor. Put the anchor. So this is the one thing we can do. We can just maneuver because with the momentum, we can use the momentum of the ship and at least we can go to the area and we can put the anchor. So at least for that we required a direction and that direction we can take from the solars. So it is for the safety of the ship or safety of the navigation. This is still it is being used. Now it is having the two illuminating lamps. Okay, two illuminating lamps are fitted in this one. Lamps are fitted. One is powered from the 24-volt DC supply and dimmer in wheelhouse. And second is supply from the ship supply. Ship supply means that is the domestic supply, 100 volt or 220 volt AC supply with we can say with dimmer and here also with dimmer in the wheelhouse. So we are going to have this one. Okay. So dimmer is also there. So brightness also we can use. Now, how to read that is the one thing is there that it's supposed to be available. This one, as per this regulation, you can see to determine the ship's heading and display the reading at the main steering position. Because the person navigators cannot go if everything fails. In that case, they cannot go to the Monkey Island for this one, but there is a provision that is being made. And that provision is a periscope-like arrangement is there. Okay, periscope. I think everybody know about the periscope. So a periscope arrangement is made to view the compass card from wheelhouse. Okay, compass card from wheelhouse. So that periscope arrangement is there, and with that arrangement, it can be seen. So if it is located in the Monkey Island, we can see from the wheelhouse. This is there, you can see here. This is the pinnacle of the magnetic compass. Okay. And we have the periscope tube, and this is the mirror where we adjust and we can see the dial. So here is the dial is there, which we can see through the. So this is the periscope type arrangement is there. Now, the magnetic line which are there, the magnetic lines of Earth are not straight. Are not straight. So it is not a straight, not straight lines. Now, if it is not straight, that means the direction can be wrong. Okay, that means card readings will vary. Card reading will vary place to place or region to region. Yes, it is going to vary. But generally, it is known which region or place it is going to vary. And that's why it is being corrected by placing characters. That is known as a characters. So there is a many types of characters are there in this. Okay, I will list a few in this one. And that characters are quadrantal spheres. You might have seen two spheres like this, where the pinnacle is there of the magnetic compass. Okay, you might have seen like this, it is located. Everybody has seen black color, two spheres. So these spheres are known as the quadrantal spheres. This is a soft iron and it is placed, so it can move. It can move in this direction like this. So it can also correct the reading. Okay, it can correct the reading. Then it is going to have a Flinders bar. This is for the vertical corrections, vertical soft iron correctors. And this one is a horizontal soft iron. Then there is a fore and aft corrector. And there is a athwart shift corrector. Now, why I am saying this one? It is nothing like that you have to do anything. It is just I'm telling you because sometimes you might have experienced. If the ship is going to the Canada or south of Australia, you might have seen that there is a error between the magnetic compass reading and gyro reading. Gyro compass reading. And if the reading is going to be more error, the error is going to come. That gyro error comes. That is the thing. Magnetic compass error doesn't come, the gyro error. Why gyro error comes? Because the gyro takes the reference from the magnetic compass. The magnetic compass itself is not aligned to the magnetic north. And that's the reason why it is going to give the error. Okay, gyro error comes. So, but basically it is not a gyro error. It is a magnetic compass error, and generally in this area, because the deviation is going to be much, much more, and that's why these alarms that is going to come. Okay. So if you are going to be in this area and if you are being called, then you try to tell them that this is because of the magnetic declination. Magnetic declination. This is the one word, just remember this one. Okay, I'm putting here. And that's why we need this corrector. So they need to correct it. Generally, they try to put everything on the ETOs. Okay. On what says you might have also seen everything, any alarm or anything is coming, just put on the head of the ETOs. Now you can see this is a magnetic line and this is not a straight. This is here, it is a south pole, magnetic south pole, and here it is a magnetic north pole. So if you are in this area, generally there is a difference that is going to come. And if you are in the area of the Canada, it is not shown here, the Canada is not there, but if you are in that area, again this problem is going to come. The error will come, 101% error will come. And in this area, if you are there, tell them to put the corrector and correct it. They are knowing in which all area it has to be corrected because it is given in their charts. Okay, and it will be coming. So try to tell them about that. Now, like I have told you during the starting that we can select a magnetic compass. Here I have told you. So like we are going to give the bearing repeater. If we are going to have a bearing repeater, okay, I'll make this slide. If I am going to have a bearing repeater in the wheelhouse, generally we are going to have the bearing repeater. This is mounted in the wheelhouse. This is going to be mounted in above front window. Okay, in above front window, above of front window. So this is where it is going to be mounted. Okay, above of front window. Just front window is there. Above that, you might have seen this one is there. Then there is a autopilot. In the autopilot also, you are going to have a bearing repeater. Okay, this bearing repeater is here. So these all places. So this is basically help the helmsman to see the bearing repeater and steer the ship. Now this bearing repeater which is there, it is having a selector switch. So you can see in the wheelhouse or BCC where the bearing control console, bridge control console is there. In this, the signal which is going to come from the mag compass, it is going to come from the gyro compass, and also it is going to come from the GPS. Now we have a selector switch. Okay, so this all can be selected. So magnetic compass, it will be written mag, gyro, and GPS. Okay, so this is going, it will be going to all the bearing repeater. Wherever the bearing repeaters are there, not only the wheelhouse and autopilot, but other places like bridge wing, breeze wings and all also having the this bearing repeater. Steering gear room is also having the local positions, also having the bearing repeater. So this all places we have this bearing repeater. Now this bearing repeater, it can show the magnetic signal or the gyro signal or the GPS. So from this it can be selected for the display purpose. Okay, but we know that there is no power supply to the magnetic compass. Then how it is going to give the signal? Okay, how it is giving the signal? So it is having a flux gate sensor. I hope if you have heard about this flux gate sensor, and through that this signal is means the position, the orientation of the magnet is being sensed, and it is going to give the ship's heading. That is basically ship's heading signal that is given to the gyro compass or the selector switch. Okay, so here you can see. I hope if it is clear, little bit I can make it little more bigger. Okay, so this can be clear here. You can see there is a AC lamp that already I have told about this in the binnacle inside, and this is the DC lamp, and this is having the dimmer. So here we are going to have the dimmer in the steering stand or wheelhouse. That is. Then we are going to have an indicator how much the bearing, magnetic compass bearing is there. Now how this is coming, you can see here a small, here the flux gate sensor that is being used. What is this flux gate? This is a non-contact sensor. What it sends? It sends the position or orientation of the magnet. Okay, accordingly, it is going to generate the signal. So this signal that is known as a bearing signal or ship's heading signal. We can write ship's heading signal. So this ship's heading signal that is taken. Now this is a non-contact sensor. Remember, this is a flux gate. Okay, it is going to sense and it is going to give to this device. This is the indicator actually. Indicator. And it is also interfaced with the like gyro compass, autopilot, like this. Autopilot means here we have a selection in the autopilot. That's why. It is going to the gyro compass for the reference purposes and also the selection. When we change the selection, it is going to show the gyro compass reading or the magnetic compass reading. And both the things are depends upon model to model. Generally, these all selections are there in the Sperry Marine. If you see, it is there in the wheelhouse itself. If some other makes are there, Japanese made, then it is there in the autopilot itself. Okay, in the autopilot we have these selections. So likewise, it depends upon maker to maker where they are positioning this. Okay, so this is how signal also magnetic compass signal that is going to come. Of course, when the power supply is not there, this signal is not going to work. Then physically, that is the periscope arrangement is there. We can see this and we can maneuver. Okay, we can maneuver the ship. Okay. Now let's see about the. Okay, any doubt up to here to anyone? Any doubt? Magnetic compass and all.
So what was the name you told when there is a difference between magnetic compass and gyro reading?
No, that is goes for the it is gyro compass. It is given for the reference. It is given for the reference. So that if there is a difference between the reading of the gyro compass and the magnetic compass, then it is going to give the alarm. And that alarm is a reading error in the gyro. That is.
Excuse me, sir.
Yeah, tell me.
Sir, that corrector will be used only when we'll go to Australia and Canada.
Generally, in this area, it is going to happen.
So, is there any alarm will be raised?
That is what I am saying. Gyro reading alarm will.
Okay.
Gyro is not having a trouble. Huh? This is due to the magnetic compass because there is a deviation, and that deviation has to be corrected. And this is corrected by the this correctors. Okay. Now let's see about the gyro compass. Okay, gyro compass. Okay, we'll see about the gyro compass. Just you can take a break for 5 minutes and continue this gyro compass.
So one doubt, sir.
Yeah, tell me.
Sir, as you said that magnetic compass is located on the Monkey Island, so that there is no current carrying cables. And after that, you told that we have to supply the 24-volt DC and 220-volt AC supply for illuminating lamps.
Yeah. Yes, yes.
So, sir, is this contradictory that both lines?
No. See, the lamp, how much the current it is going to carry, and how much the magnetic effect will be there. That depends, no? I'm talking about the cables. If the big cables are there, their magnetic effect will be there. In that case, there is going to be a deviation. For this indicating lamp, that is hardly is going to have any current in that one. It's a very small current.
Okay, sir.
It is not going to impact that card.
सर थोड़ा बेयरिंग रिपीटर थोड़ा फिर से एक्सप्लेन करो
Sorry?
सर बेयरिंग रिपीटर थोड़ा रिपीट करो
Bearing repeater. No, where you have not understood in the bearing repeater.
नेटवर्क थोड़ा कट गया था तो थोड़ा समझ में नहीं आया
Okay. What I have told in that one is that here, if you see this was the diagram, what I say, what I have told that one is we have a selector switch. Selector switch. So generally, this is either it is located if it is a Japanese made and there is what is the name Tayo or something is there, that is the maker. In that case, it is going to be in the autopilot where the gyro is there, just below of that one. Autopilot, below that we have the gyro. Okay, so that's why it is written autopilot there. So we beneath the autopilot, below there is going to be a gyro, single gyro. Okay. In that case, you have a selector switch for the magnetic compass, gyro compass, and GPS. So whichever is selected, generally it is selected to the gyro, normal condition. But in case of emergency, you can select the magnetic compass or GPS. So in that case, wherever the bearing repeaters are there, they are going to be connected to that signal. So these signals of the sixth heading, which is coming from the magnetic compass, gyro compass, or GPS, whichever is selected, that it is going to show in the bearing repeater. So these bearing repeaters are located in the various places like bridge wings, wheelhouse, then autopilot, then there is a this steering gear room. This all places there is a bearing computer. Okay, this I have told about the bearing computer. It's clear?
Okay, sir. Clear.
So means you are telling that if we will install a higher capacity bulb, then there will be error on the magnetic compass.
No, higher capacity bulb means how much the it is just a 40-watt bulb that we are going to use. It is a small bulbs, no?
Yes, sir.
Yeah. Why you want to use more bulbs, more higher capacity? No, it is made in such a way, if you see where it is illuminating, how much the distance it is having from the magnet. And it is a small current which is going to be carried by this illuminating lights wiring. And this wiring is very much secured, so it is not going to have any impact. What I am talking about, that the big current carrying these cables are there, they are going to impact this. So generally, these cables are not laid between, means nearby to this binnacle of the magnetic compass. And there is a binnacle also. Binnacle, why it is there? Because it has to maintain a height, certain height from the deck to above. And that's why the binnacle is there.
Okay.
Okay, take a break of 5 minutes and we'll start with the gyro Okay, welcome back. Now gyro compass has given it is given in the solars again same. Chapter 5, safety of navigation, regulation 19, 2.5. So it is given that all ships of 500 GT and upwards and in addition means like magnetic compass and all what was there in addition. A gyro compass or other means to determine and display their heading by shipborne non-magnetic means being clearly readable by the helmsman at the main steering position. Then it says that these means shall also transmit heading information for input to the equipment. Now remember here many things are there together, just see one by one. One is the 500 GT and upwards, that is there, very clear. Okay, it is saying that ship-borne non-magnetic means. Now, the magnetic compass was the magnetic means. That means we should have a separate compass which is not going to work on the magnetic means of the earth. So it's supposed to be the non-magnetic means. So it's a very clearly it is saying it is not, it should not be a magnetic compass. So it is clearly differentiating between the magnetic compass and the gyro compass. Second, being clearly readable by the helmsman. Helmsman, where main steering position. Main steering position is a wheelhouse, where the autopilot is there. These means shall also transmit heading information for input to the equipment. Means all the equipment which is going to be required this gyro information. Now, which all equipments are required? One is the radars, both the radars, exist, okay, and autopilot. So These all are interfaced. Basically, gyro information interface to this one. And there is one more is there that is known as a rate of turn. So rate of turn is also extracted from the gyro itself, rate of turn. This is the equipment itself which is going to show the rate of turn. Okay, when the ships is continuously changing, turning, that time it is going to give the rate of turn. That is required. Okay. So this all and any other also wherever the gyro is required inputs that has to be given. So that is supposed to be interfaced. Okay. Now next it is saying that is the SOLAS requirement is a gyro. Okay, someone says gyro, that is okay. Okay, in the English, nothing like that. If you say gyro, it's okay. If you say gyro, it's okay. So gyro compass heading repeater. Heading repeater. Now it is clearly saying gyro compass heading repeater. That is what we say bearing repeater. Okay. Or other means to supply heading information visually at the emergency steering position. Emergency steering position if provided. Emergency steering position, if there is a emergency steering position, if it is provided, then this information of the gyro compass heading repeater will supposed to be given. Then a gyro compass heading repeater or other means to take bearings over an arc of the horizon of 360 degree. That means we have the horizon all around us 360 degree. So there's supposed to be the gyro compass heading repeater. Now what this gyro compass heading repeater is saying? You might have seen there is a gyro compass heading repeater is there in the bridge. Okay, just bridge you will find at the center window below of center window you might have seen. Okay, there is a bearing repeater. In that that we are going to put one navigational equipment. Suppose this is a gyro, and in on top of that you might have seen something like this. One instrument that is kept like this. Okay, something like this, and there is something which is made something like this. Okay, this is basically for seeing the or for determining the bearing. Why it is required to determine the bearing? or take the bearing? We are going to take the bearing so that we know that whatever our gyro magnetic compass or GPS are giving a correct reading or not, are giving a correct reading or not. So this is when the gyro magnetic compass and GPS were not there. Okay, in that case, this instrument was always used for fixing, taking bearing means fixing the bearing of any object. So what is the non-objects are there? Their bearing are being fixed and it can be determined. So for that, this instrument is required. And we can calculate and we can find out if there is a correct reading is there or not. And that's why this repeater is supposed to be there. So where these repeaters are there, one is in the bridge, inside the bridge, and two are there in the bridge wings. Bridge wings. So you might have seen in the bridge wings, one is the port side and one is the starboard side. There is a binnacle, and on top of the binnacle there is a gyro compass heading repeater. So that is known as a gyro repeater. So in short, we say gyro repeater. And that is there to take the bearing, means to fix the bearing of any object. Any object, non-objects is there, we can fix the bearing. Fix the bearing means not of the object, but our heading that is correct or not from that object. We want to find out our own ship bearings. Okay. That is the purpose. So they navigators, they do it with this instrument. So we are not going to do anything with this, but you should know that this is what means why it is required. You might have seen in the bridge wings also bearing repeaters are there. In the bridge below of the center window, front window, you will find one. This bearing repeater is there. So that is about the SOLAS requirement. Now next we are going to learn about the gyroscope. 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 Gyroscope is basically any spinning body is known as gyroscope. Okay, any spinning body is known as a gyroscope. So, can you give me any example of the gyroscope? No, no example is coming.
Gyrosphere.
Yeah, gyrosphere is there and okay. The best example of this one is a Earth. Okay, our Earth is also a gyroscope. It is continuously rotating at the same speed and it is continuously maintaining the spinning axis. Okay, so you can have this example. Okay, Earth or Moon or any space, extraterrestrial, anything, satellites, they are orbiting. So these all are known as a gyroscope. Okay. Or rotating means spinning by themselves, the spinning body, that is known as a gyroscope. Okay, so one point is very much clear now here with the example itself. So we can say our Earth or globe That is the example. Then we can have the moon, likewise we can say it. Now it is going to have this gyroscope is having two basic properties. Now you look at the earth, you will find these two properties are there. Okay, one is known as a rigidity, and second is known as a precision, not precise. Huh? Precise is different. Precision. Okay, so there are the two properties are there. What is these two properties? Rigidity, that is what I have told you here, that the earth which is rotating, oh sorry, is spinning, not rotating. Okay, we can say rotating also, there is. So, okay, and it is spinning here. And this is spinning axis in space is always pointing to the same position, pointing to same direction. They never changing. So this is a spinning axis. And this is spinning axis pointing in space, pointing to same direction in space. Okay, so this is known as rigidity. This is known as a rigidity. Okay, this is known as a rigidity. So rigidity means we can say the axis of rotating, the axis of rotating or spinning, we'll say spinning only, the axis. Okay, the spinning axis will just cut short something. The spinning axis of a spinning gyroscope tends to remain in a fixed direction in space if no force is applied to it. It is also known as gyroscopic inertia. It is also known as a gyroscopic inertia. Rigidity, inertia, rigidity. Okay, so this is always going to point to the same position, with same direction, fixed direction, same fixed direction in space. So this is known as a rigidity. Like Earth, we can give this example. Okay. Now next is the precision. So this is more interesting, precision. Now if there is an external force then what will happen? This rigidity we are saying if there is no external force is applied to it. Okay, no external force. We can say I think external force applied to it. Now, if there is going to be a external force, then what will happen? Okay, let's see what is going to happen. The spinning axis has a tendency to turn at a right angle, the spinning axis has a tendency to turn at right angle to the direction of applied force. What it is saying is, suppose there is a spinning body. I will just put that photo itself, that will be much clearer. Because making a picture is, you're not going to understand. So this is what the gyroscope you can see here. And this is talking about the precession. Now, can you see this is a spinning axis? This is a spinning axis. So it is at almost 90 degree. Okay, it is having, this is the spinning axis. Means we are saying from here, this is a 0, this 90, 180, 270, likewise. So you can say this is the direction of the spinning axis. Now there is a force applied to it. And this is known as a gravitational force. If the gravitational force is there, it is not going to fall down because it is rotating. This is a gyroscope. This is a gyroscope. And this is a spinning gyroscope. So the spinning gyroscope is there. This spinning axis, you can see now here, it is fixed only in one side. Other side is not fixed anywhere. It is just not fixed anywhere. And it is spinning at the very high speed. With the gravity, it is not going to fall. It is not falling because of the rigidity. Spinning axis having the rigidity. Okay, due to that, it will never fall. Okay, they are not going to fall down. But there is a force applied to it. Then what will happen? Now you can see here, it is turning. It is turning like this. It's turning. Okay, at the right angle of the applied force. So here if you see this one, this is a right angle, 90 degree. So if the applied force is downwards, it is rotating like this. Now why it is rotating clockwise direction? It can rotate other side also. Why it is clockwise only it is rotating? Because gyroscope is spinning in the clockwise direction. If the gyroscope is going to rotate in the counterclockwise direction, a precession means at the 90 degree of the applied force, that is going to rotate, that is the precession will happen in the counterclockwise, means opposite to this, and that is known as precession. So precession will happen in the counterclockwise. Precession will have in the clockwise if the spinning gyroscope is clockwise direction. If the spinning gyroscope is counterclockwise, the precession will happen in the counterclockwise direction. Okay, hope it is clear. Now these two property of any gyroscope that is being used. Okay, that is being used. So how it is being used, we will see that one now. Next. So let's understand first about the gyro compass, then we'll go for the gyroscope and this up. Okay, we'll try to understand one by one. So I am writing about the gyro compass first. So it is a north seeking device which provides direction of ship's heading. Ship's heading. Okay, direction of ship's heading. It is having gyrosphere which settles to the true north pole and unaffected by the magnetic lines of Earth. Now let's see about this one. So it consists, means gyro compass consists of a gyro sphere. So already I have told you gyro sphere which houses two gyroscope. It can have one also. It can have two also. It depends upon maker to maker what they are making. Now it is the gyro sphere that is having the two gyroscopes, okay, inside that one. So what we are saying is, suppose we are going to have a gyrosphere. So suppose this is a gyrosphere. Inside this, we are going to have, okay, two gyroscope. Okay, two gyroscope is there. This is the spinning axis and this is the other spinning axis. Here, like this. So this is the spinning axis. So there is spinning axis is connected at the 90 degree. Here, mechanical. This is the mechanical linkage between the spinning axis of both. Okay, and this is at the 90 degree. So we are going to have the two. First of all, this one is a gyro sphere, and inside this we are going to have a gyroscope. So this is a gyroscope and this is a gyroscope. Okay. Now, it also, so this gyrosphere floats on supporting liquid, liquids. Okay, so this is going to floats on the supporting liquid of supporting bowl. So there is a bowl. So we are going to have a bowl here like this. This is a supporting bowl. So this is known as a supporting bowl. And there is a supporting liquid here. Okay, and this is a supporting liquid. And this sphere is going to float on the supporting liquid, which is in the supporting bowl. Okay, now this supporting bowl is fixed in binnacle. Generally, that is known as a binnacle only, or gyro stand binnacle by gimbals. So here also we are going to have the gimbal. So like we are going to have the, here this is the gimbals fixing, and around this we are going to have the gimbals, and it is going to be fixed. Now how the gimbals look like? It is a ring, you can say, like this is a one ring, and here there is a connecting. Again there is going to be a third ring like this, and here it is going to be connected. Again there is going to be one more ring. So it is going to have a 3 degree of connections, and here at this point we are going to have the bowl. So this is a bowl, supporting bowl, and it is going to be connected with a gimbal. 3 gimbals means 3 degree of freedom. That's it. Okay, so it will look like this from the top. With the top view, it will look like this. Okay. Now, this gimbals is a, sorry, this gyrosphere is a sealed unit. Then only it is going to float. Okay, so gyrosphere is a sealed unit. Sealed unit. Now, if it is a sealed unit, how the gyroscopes they are going to rotate? Now, what is gyroscope first of all? Gyroscopes are squirrel cage induction motor, SCIM. SCIM, squirrel cage induction motor. Again, I am repeating, SCIM, squirrel cage induction motor, mounted inside the gyrosphere. With their spin axis is at right angle to each other. So this is a SCIM, a squirrel cage induction motor. Now squirrel cage induction motor is there. Then it's supposed to rotate basically. Sorry. Now it is going to rotate. Yes, it rotates. Now what is the speed of this one? So gyrosphere or squirrel cage induction motor, SCIM, is fed with 100-volt AC and 337 hertz frequency, single phase supply, which attains a speed of nearly 20,000 RPM. Remember this. Okay, 20,000 RPM. So this is your supply, and this is the gyro scope, that is the SCIM, that is going to rotate at the 20,000 RPM. Okay.
Sir, sir, for 220 volt AC, the ship designed voltage, it will be different, no?
Yeah, it is going to be 60 hertz only. So
Okay.
what should use here? What we should use here to enhance our frequency?
And sir, this frequency is fixed for all the gyroscope, or it is depend on the models for?
No, it depends.
Okay, okay.
Yeah. It is not fixed. Just I am giving one example. Okay. This is generally for the Sperry Marine. This is there.
Okay.
This is the VFD. You know something like VFD? Variable frequency drive?
Yes.
Yeah. With that only we are going to get this 337 hertz, because our input supply is going to be 100 volt, 60 hertz. So this is our VFD which is going to give this supply. 100 volt, 337 hertz, single phase. Okay. So we are going to have a 20,000 RPM. So when it is going to reach to that RPM, the resultant spin vector and with it the sphere, the gyrosphere, always settles in the direction of true north. Okay, it is going to always settle in the true north. Okay, now how the supply is given? Because this, suppose we cannot put any wire directly to this one. So there is no wire is going here. That means we are going to have a pickup. Here there is going to be a pickup inside the sphere. Here, this is a conductive metal that is being put. Rest other areas it will be a paint. And here also we are going to have a conductive metal. Okay, conductive metal. Generally the brass strips that is being put here also, and it is totally sealed. Okay, nothing can go inside. Then we are going in the bowl also, there will be a coating. Non-conductive coatings will be there. And here we are going to give a supply. So this is the supply. And here also at this point, we are going to give a supply. And this is a single phase supply that will be going. Okay, this will be going. So this is the 100 volt. 337 hertz. Single phase this supply is given. So the current is going to flow in this one here. Okay, and from here it is given to the motor. Okay, it is given to the motor like this. Now here also the current is going to flow. Okay, so and from, okay, I have given both from the same place, sorry. That one is coming from here. Okay, this is the single phase supply. This is how it is given. This is not going to get short circuited because from here to here the resistance is very high. Only this is the nearest, the resistance is low, so it is going to conduct, but from here to here the resistance is going to increase. So it will not get short circuited. Remember this one, it will not get, supply will not get short circuited because the resistance are more. That means this liquid, which is a supporting liquid is there. This liquid is also known as this one, this liquid. It is also known as electrolytically conductive fluid. Okay, conductive fluid. Electrolytically conductive fluid. Now, what all things are we are going to mix? So electrically it should conduct. So again, it is going to have the same distilled water, what we have seen. Distilled water plus glycerin plus alcohol. So alcohol, glycerin and distilled water, it is same, but one more thing that is added, that is known as a boric acid. This boric acid, which is going to make it electrolyte because this is acid, and the current is going to conduct through this. Otherwise, rest all, it is a non-freezing element, and these two are used for the density, to increase the density so that the sphere should flow. But boric acid, which is making it conductive. Okay, it is making it conductive, means the fluid is going to conduct. So that's why it is given through this one. Okay. So this is how it is going to always settle in the direction of the true north. True north. Okay. Now, what happens when the ship is going to turn? Now, just see here. We should understand that this is mounted on board a ship. Suppose this is a ship. This is a ship. And here we are going to have a gyroscope. Okay. And this is a true north. This is the 0 degree, or I'll say this is the 0. This is 90. This is 180. And this is 270. 0 means this is a true north. True north. And this is true south. Now ship is in this direction, this direction. That means here one ship is going to be made. Means that marking will be there like this. And it is going to show the direction. What is the direction? So we can find out the direction. Now suppose this ship is changing the direction like this. If it is changing the direction, okay, that means this is changing the direction and it is going to be fixed in that position. So basically there is going to be a relative motion, correct? If we see, if suppose we are seeing the gyro card, you will feel like gyro card is rotating, but it is not rotating. It is remaining in same position true north and ship is rotating. Okay, it is turning, basically ship is turning, but it looks like that gyro card is turning. Okay, so it is always going to maintain to the true north. Now, what is the ship's heading it is doing? How we are going to transmit that signal? So what I am trying to say you that the sphere, this is a gyrosphere, which is having a card on that one, and it is always maintaining, because gyrosphere is maintaining always the true north. And suppose the ship is turning, so that means it is going to have a relative motion in this direction. It is going to have a relative motion. Okay, so there is a follow-up system. That follow-up system that is going to be on top of this. Like this, there is a follow-up system. And this is connected with the ship, means this is turning, to the clockwise direction. Whereas the relative motion of the gyrosphere is anti-clockwise. Oh, sorry. It is going to be the counterclockwise like this. So what happens? This has to be a pickup, and that pickup is going to sense that what is the deviation between these two, follow-up system and this. So this card should always align with the gyrosphere. So how the aligning is going to be done? That means there has to be a sensor between this. So there is a sensor. Okay. Now just come to the alignment positions you come to know. So suppose there is a sensor which is sensing the deviation between these two, means alignment of the card and this one gyrosphere. If there is going to be a deviation between this, it is given to this amplifier is going to drive a servo motor. Servo motor is there. Okay. And this means deviation, and this deviation has to give the deviation, means how much the deviation is there. So that amplifier, it is given the servo motor, and servo motor is going to rotate the follow-up system. Follow-up system. Follow-up system means where the card is given, this card. Okay, because this is rotating with the ship. That means it has to be brought back. So what I am doing, I am just putting a servo motor here, and this servo motor is being rotated by the amplifier, by deviation. Sensor deviation amplifies servo motor. Servo motor rotates this one, and it is always keeping aligned with the gyrosphere. So this is known as a follow-up system. Okay. And in that way also, we can have the signal, heading signal. And that heading signal is can be amplified. Because how much it is turning to this card, that is going to give me the signal, heading signal. And that is given to all the places wherever it is required. So we are going to, that is known as a retransmission unit. And there is going to be a follow-up control and there is a retransmission unit. So like this, your data of the gyro is being transmitted to the bearing repeat. Okay, I hope it is clear. I will give you a small notes on the follow-up because it is required. Just write down a follow-up control circuit is a bowl. Bowl we say or will not say the bowl. Yeah, it is a bowl only. Okay. It's the bowl. Oh no, we'll say not bowl. Keeps the card. Then the card is then mounted on that. Aligned with the gyrosphere. It all time. A sensor is used to sense the deviation of card and gyrosphere orientation. Okay. It is going to sense. Generally, this is known as a optical pickup. Nowadays, the optical pickup is there. Before they were using the transformer. Okay, that is the differential type transformer that was being used. Now it is they are using the optical pickup. This is amplified. This signal is amplified and given to the servo motor which rotates the card to have or to align with the gyrosphere orientation. So gyrosphere with gyrosphere, just I am writing with gyrosphere. Okay. Because gyrosphere, this orientation of the card is going to change to align with the gyrosphere. So always it is going to. And thus the ship's heading means how much the card is moved clockwise or counterclockwise. That is going to be the shift heading. Okay. So how much we can say how much the card is being rotated, provides the shift heading. This shift heading signal is transmitted to the various or to the bearing repeaters located at various places. At various places. Okay, I hope it is clear to everyone. So this is the follow-up systems. Any doubt to anyone up to here? Any doubt?
So what are the problems we can face with this magnetic compass and gyro compass, and how to solve all those problems?
Generally, you are going to get the problem of like gyro itself is not aligning to the north, true north. Okay, or there is a difference between the gyro and magnetic compass. So already I have told you how to solve the magnetic compass. Gyro compass, how you come to know that there is an error. So they have to find out navigator. That is what I have told you with this one. This instrument is there. There is a bearing instrument, navigation instrument. With that, they can fix any object. They can take a fix of the sun also, stars also. Okay, and they can find out the direction, the ship's direction accurately. And they can check that gyro heading, what it is giving, it is correct or not. If it is not correct, then means there is some problem. Onboard ships hardly we do anything in that one, but minor corrections we can do in that. But you supposed to have the like supporting liquid and all. And if you want to change the sensitive element, this is known as a sensitive element, that is the gyrosphere. Okay, if you can do it, you can do it on board ship also, if you have the spares. If you do not have the spares, then only the shore technician generally they come and they do it. Otherwise, you can't do anything. At most, you can just reset the systems. You can switch off the power supply. Again, you can switch off. Okay, but remember this one, when you are going to switch off the power supply, the ship's heading should not change for at least 3 to 4 hours. Because once you switch off, and again the gyro is going to align to the true north, it takes 3 to 4 hours at least. So ships is moving, then it's supposed to maintain always one direction. So try to take these precautions whenever you do anything. Otherwise, with the bearing repeaters and all, it is just a signal which is being transmitted and given. So there is a servo amplifier, there is a servo motors. So at most, the problem that is going to come with the servo motors and servo amplifiers. Now, when we are going to have a difference between the gyro card and the bearing repeater, then there is a self aligning. There is a push button you can see. You can press that one. So self it can align with the gyro compass. Automatically it is going to align. So these all things you can come to know with the manual. Otherwise, problem solving is very difficult in this. Only you can see like your power supply and everything is okay. That's it. Interfacing devices, if they are not going to receive any of the signal, you can check that one, the continuity of the cables and all. Okay, that much only you can do, otherwise you can't do anything in this. Okay. Any other questions? Okay then. Happy New Year to everyone and thank you. Thank you very much. Good night to everyone.
Happy New Year, sir.
Happy New Year, sir.
Happy New Year.
Thank you.
Happy New Year.